Hi, this is Kim Breeden at Minnesota Online High School. In this video, we're going to learn substitution, a second way to solve systems of equations. Previously, we've learned to solve systems of equations using graphing. Now, that might be the easiest method overall if you always have access to a graphing calculator, and also if they're smaller numbers. Sometimes you've noticed that we had to zoom quite a ways out, so that made it a little bit more challenging. We're going to work on how to do them using algebra and substitution. And there will be times on your assignment or on your test where I do specifically ask you to use substitution and will want you to show your work. Learning multiple methods is really important. So there are some general steps to solve a system of equations. First off, we have to get one equation solved for a variable. This means we want it to look like y equals or x equals. Sometimes, if we're lucky, this will be done for us. If not, we want to pick the variable that's easiest to solve for. If neither one is easy to get x or y by itself, maybe this isn't the best method. Once we have an equation written for y or x equals, we put that value back into the other equation. Then we're going to take that new equation and we're going to solve for that variable. At this point, we should only have one letter in the equation. We have to find our values for x and y. So once we get our answer for the first variable, we're going to take that answer and put it back into that equation from step one. And then we always want to check our answer. In this case, your answer should be an ordered pair. And we want to make sure that the answer works for both equations. Now we're going to substitute. So this means we're going to take that equation that is solved for y, and we're going to substitute into the other equation in place of y. Since y is equal to 3 plus x, we're going to take that and put that into the y spot up there in equation 1. So I'm going to substitute, and this is going to become x plus, now instead of y, I'm going to put 3 plus x equals 5. We can just write this out as x plus 3 plus x equals 5. I'm going to combine like terms. So I have two x's. So x plus 3 equals 5. We want to solve this for x. So we need to subtract 3 from both sides. So 2x equals 2. If we divide both sides by 2, we will have that x equals 1. Solving the systems of equations is going to give you an ordered pair as an answer. You need to know x and y. Well, on the last slide, we already decided that or discovered that x was equal to 1. Now we have to solve for y. So I like to pick the simpler equation, and let's substitute x equals 1 into that equation. So we have y equals 3 plus, instead of x, I'm going to put 1. Well, 3 plus 1 equals 4. So x is equal to 1, y is equal to 4. Get in the habit of either very clearly organizing it like that, where you have an answer for x and y, or you could write it as an ordered pair. X always goes first, so 1 comma 4. Now we do want to check our answer. To check our answer, we put it back into both equations. And let's see if this is true. So equation 1 said x plus y equals 5. Well, is that true for 1, 4? 1 plus 4 equals 5? Yes, that works. Now let's check the second equation. Y equals 3 plus x. Okay, put in 1 and 4. Y was 4, x was 1. Again, that is true. Remember, a system of equation needs to be true. A solution to the system needs to be true for both equations. Solve another system. 3x minus y equals 4, and x equals 4y minus 17. Step 1 says solve an equation for one variable. Well, again, here we're lucky because down here I have x equals. We're going to take that, and since x is equal to 4y minus 17, that goes into the other equation in place of x. I like to write down the equation 3, and then I'm going to leave a spot for x, minus y equals 4. Okay, in there, I'm going to put in what what x was equal to. So 4y minus 17. We substituted in. Now we're going to have to solve this. Think back to solving equations. This one's a little bit more complex. We're going to have to distribute. So our first step is to multiply that 3 in. Well, 3 times 4y is 12y. 3 times negative 17 would be plus negative 51 minus y equals 4. Let's combine like terms. We have 12y minus y. That gives us 11y. 11y plus negative 51 equals 4. Or you could think about that as subtraction. 11y minus 51 equals 4. So we're going to add 51 to both sides. So 11y equals 55. To solve for y, we're going to divide both sides by 11. So in this particular case, y is equal to 5. Now, I know you feel like that was a lot of work. You might be tempted to quit. But we need to find x and y. Since we know that y is 5, now we're going to use that other equation, and we're going to solve for x. So x equals 4 times y, well, 4 times 5, minus 17. So x is going to equal 20 minus 17, or 3. Now again, I can very clearly label my answers as y equals 5 and x equals 3. Or better yet, I'm going to write it as an ordered pair. Be careful, because even though we found y first, our ordered pairs will always be x comma y. You might have a problem where neither equation is solved for x or y. So that's going to be our first step. Step 1 is to solve an equation for a variable. Now in this case, it's going to be easiest to solve the top equation for x. I can tell that because x does not have a coefficient in front of it. So 3y plus x equals 7. Well, I want to get x by itself, so I need to subtract 3y from both sides. So that means x is equal to 7 minus 3y. Now we're going to take x equals 7 minus 3y, and in the second equation, we're going to substitute that in for x. So instead of 4 times x, I'm going to write 4 times 7 minus 3y, and then I continue the rest of the equation. Minus 2y equals 0. We're going to solve that for y by first off distributing. So multiplying in by 4. 4 times 7 is 28. Remember, I could rewrite that subtraction as adding a negative 3y. So 4 times negative 3y is negative 12y. And then I add minus 2y, which is the same as adding negative 2y. And that's going to equal 0. Okay, now I'm going to combine my like terms. 28 equals negative, I'm at 28 plus negative 12 plus negative 2y is going to be negative 14y. And on the right, it was equal to 0. I need to get y by itself. Well, that 28 is added to it. So I'm going to subtract 28 from both sides. Okay, pay attention to what we have on the left. There still was a negative. So that's negative 14y equals negative 28. Divide both sides by negative 14. Negative 28 divided by negative 14. That tells us that y is equal to 2. Once we know that y is equal to 2, we need to find our other variable. Pick the equation that looks easiest to work with. I think that's the top equation. So 3 times 2 plus x is going to equal 7. So 6 plus x equals 7. Subtract 6 from both sides. So x is equal to 1. So our answer, x equals 1, y equals 2. If we write that as an ordered pair, that's 1, 2. A reminder, you can always check your solution. For time's sake, I'm going to skip that in this video. But remember, we've learned a couple different methods. There are times when solving by substitution is going to be easier. So again, if you don't have a graphing calculator, or if you already have an equation where one of the equations has a variable that's been isolated, so like x or y equals. Stay tuned, we'll learn one last method in our next video.